Hi everyone, welcome to lecture 3 of week 12. So today we will cover the physical technology layer of smart cities. Now think of the smart city as a human body. The AI which we covered in lecture 1 of this week is a brain. The blockchain from lecture 2 is the memory, and the 5G what we will cover today is the nervous system. It connects everything together and carries information at a very high speed. Now without fast reliable connectivity, AI has no data. Sensors cannot send their readings, their data. The whole smart city stops working. So the 5G technology is the fundamental requirement for the smart city, not optional. We will also try to look at drone and surveillance technology for the smart city. So let's start with. Most people think the 5G means faster internet on their smartphone devices. That is wrong. 5G has three special qualities as compared to 4G. The first quality is it has ultra low latency. The 4G responds in 30 to 50 milliseconds. However, 5G responds in under 1 milliseconds. Now, why does it matter for smart cities? Let's suppose a car is traveling at a speed of 100 km per hour. So that's going to travel around 83 centimeters of distance in 30 milliseconds of time. And in 1 millisecond, it will travel less than 3 centimeters of distance. So for an autonomous vehicle, detecting an obstacle, this difference is a crash versus a safe stop. The second quality of 5G is massive connectivity. Where 4G supports around 1 lakh devices per square kilometer of area, the 5G supports around 1 million of devices for the same area, which turn out to be around 10 times more support. A smart city has millions of sensors. Only this 5G technology can connect all them simultaneously. The third quality of 5G network is its high reliability. The 5G targets around 99.999% uptime, which turn out to be less than 5 minutes of downtime per year. This makes it safe for emergency services and hospital where connectivity failure costs life. Over 1500 cities globally has 5G coverage as of 2024. India's rollout since 2022 cover most of the major cities now. So let me give you the technical specification for 5G. The speed, the 4G LTE speed is around 1 Gbps. However, the 5G peak speed is around 10 Gbps, which turns out to be around 10 times more faster as compared to 4G. Latency, as we already discussed, 4G has a latency of around 30 to 50 milliseconds. However, the 5G has latency under 1 millisecond, which turned out to be around 50 times lower. And if we see the device density, the 4G can support around 1 lakh devices per square kilometer of area. However, 5G can support 10 times more devices as compared to 4G for the same area. There are three enabling technologies which 5G uses. First is the millimeter wave spectrum. This 5G uses high frequency bands, which will be around 24 to 100 gigahertz, which carries more data but need more base stations because the signals cannot travel as far through walls. Also, they uses massive MIMO, the base station which hundreds of antenna working simultaneously to increase capacity. They can also use the beamforming. Instead of broadcasting in all directions like a floodlight, the 5G directs signal precisely at each device like a spotlight. The more efficient and having the longer range. The 5G capacity of 1 million devices per kilometer is what makes massive IoT deployment in the cities. The million of sensors, smart lights, connected vehicles all can communicate simultaneously with each other. Let's see some 5G application. So first let's start with the connected vehicles and V2X communication. The most transformative 5G applications for urban transport is V2X, vehicle to everything communication, which includes V2V, that means vehicle to vehicle communication. Your car knows that a vehicle 2 cars ahead has brake hard before even you can see those cars, and start slowing down automatically. Then we have V2I communication, that means vehicle to infrastructure. An ambulance approaching a junction communicate with traffic signals. All signals on its route turn green automatically. The ambulance never stop at any red signal. Then we have V2P communication, which is vehicle to pedestrian communication. A pedestrian step off the pavement nearby the vehicle are warned through their phone signals before the car camera can see the person. Similarly, we have vehicle to network communication, where vehicle receives real-time updates on road conditions, diversions and accidents from the city network. This impacts the safety. V2X can prevent around 80% of the crashes caused by unimpaired devices. India records around 1.5 lakh road accident death per year. The technology has enormous life-saving potential if we use them correctly. For autonomous vehicle, 5G V2X is not optional. The self-driving car needs around 10 milliseconds communication for real-time decision making. Let's see its second application on massive IoT and smart buildings. The 5G enables massive IoT deployments. Millions of low-cost sensors working simultaneously across the city. They can enable environmental monitoring. Dense sensor network can track air quality, the concentration of PM2.5, PM10, nitrogen dioxide, carbon dioxide. Also, they can sense noise, temperature and humidity across every neighborhood in the real-time basis. In cities where air quality is a public health crisis, this allows instant source identification and enforcement. This can also be implemented for smart water systems. The sensors throughout the water network can detect leak instantly, monitor water quality and can optimize the pressures. They can also implement it for waste management. The fill level sensors report bin status. The AI route garbage trucks only goes to the full bins and results into massive fuel saving. This can also be implemented on the smart buildings. The thousands of sensors per building can be implemented. They can adjust the HVAC in real time based on the occupancy. They can also respond to the light based on whether the area is occupied or not. They can also manage the energy consumption and the security. This can impact around 30 to 50% building energy reductions and 40% traffic congestion reductions. A typical smart city deployment uses over 2 lakh IoT devices, and only 5G technology can provide that capacity to connect all of them reliably. Now let's see the network slicing. Now the network slicing is one of the 5G's most powerful features and one of the least understood. Let me explain it clearly. Think of a highway with separate lanes, one for the ambulance, one for the truck, one for buses, one for private cars, one for cycles and etc. Each of lane has its own speed rules. Traffic is in one lane does not slow down the another lane. Even if the car lane is completely jammed, the ambulance lane is clear. The 5G network slicing does exactly same for the data by creating separate virtual networks within the same physical infrastructure. We can have the energy service slice. This would be dedicated bandwidth for police, fire and ambulances. Even during a massive public event when millions of people are streaming videos, this slice is untouched. Virgin's Frontline and T-Mobile T-Priority in US are the real implementation of this type of slicing. Then we can have URLLC slice, which is going to be a ultra reliable low latency communications. This will be for the applications needing sub-million seconds of reliability, like remote surgery, autonomous vehicle, and industrial automations. We can have the industrial IoT slice for factory sensors and utility monitoring. This needs reliability, not the extreme speed. We can also have the enhanced broadband slice where the speed connectivity will matter. This slicings can result one physical tower supports to all of these requirements simultaneously. Each applications getting exactly what is their requirement. Let's see the application of 5G for the emergency services. So emergency services are the most compelling 5G use case because the stakes are literally life and death. Now, how 5G transform emergency responses? There are 4 different mechanisms. First is the priority routing. The emergency vehicles get dedicated network slice. Their communication is always fast and reliable. Even during a festival with millions of people online or streaming, this would be reliable. So, next is the dynamic signal control. The traffic light detects the approaching emergency vehicles via GPS or siren detections, turning the red signals into a green signal automatically, even before the vehicle reaches at the signal. Third, we have real-time video feed. The HD video from the incident scenes streams instantly to the ambulance, is still en route and to the hospital emergency room. The doctor can see the patient even before the arrival, and they can guide their paramedic staff. Fourth, we have connected vehicle data. The patient vital sign like ECG, blood pressure, oxygens are transmitted from the ambulance directly to the hospital continuously. The emergency response team can prepare the resources before even the patient arrives. If we see some examples, we can have examples from the USA that's called FirstNet, a national public safety broadband network built for the first responders. This dedicated infrastructure always available regardless of the public network consumptions. Let us now talk about drones, unmanned aerial vehicles or UAVs. They have moved far beyond military uses and are now a practical city service tool. Their first application could be the infrastructure inspections. Traditional bridges inspections need specialist vehicle, workers in harnesses, lane closures, and days of work. A drone achieves the same result in hours. This can capture the high resolution images and videos while the traffic flows normally. And AI can analyze these footage automatically, detect any kind of cracks, corrosions, and structural deformations. This can result into 70% cost reduction, 80% time reduction, and zero human risk. For India, with hundreds and thousands of bridges, many aging and under-inspected, this is an critical opportunity. The second application could be on the emergency responses, like drones provide immediate aerial situational awareness. A fire commander has a bird eye view within few minutes. The drone can deliver the medical supplies, blood, other things faster than the ground vehicles in a congested city. The third application could be in the traffic monitoring. The aerial view of congestion and accident scenes can result into the comprehensive coverage, which is impossible to achieve with the fixed cameras. The next application we can have on environmental monitoring, where we can have the air quality sampling at different altitudes, which can be mapped with the pollution sources in 3D. This monitoring can avoid any kind of illegal dumping. However, the drone technology requires certain regulatory frameworks and safety considerations. The drone operations require clear regulation, and in India, DGCA, the Directorate General of Civil Aviation, govern this through the Digital Sky Platform and Drone Rule 2021. There are certain zones which are demarcated as no-fly zones like airports, military installations, Parliament House, state assemblies, and densely crowded areas are restricted. Drone cannot enter these zones. For safety requirements, there should be a remote ID. The drone must broadcast its identification and location in real time. Also, there should be geofencing. The drone software automatically prevents it from entering any restricted zones. And also there should be collision avoidance system in the drone. The drone should also have an operator certification. A pilot need license. The DGCA Digital Sky Platform manages registration and flight permission on online basis. There are three operational challenges for drones. First is related with the air traffic management. Coordinating thousands of drones in the city airspace is an unsolved problem at this scale. Also, the unnamed traffic management system are being developed globally. The privacy and noise concerns also create a real resistance from the citizens. Addresses this with the transparent communication and genuine community engagement can make this drone technology successful. We now reach the most ethical sensitive topic of this lecture, that is urban surveillance. I want to present both sides honestly, the safety benefit and civil liberties concern. The modern city surveillance include AI-powered CCTV cameras with facial recognition, behavior analysis, and any type of defect detections. The license plate readers, which can automatically record every vehicle's plate, location, time. There are also a social media monitoring where AI can scan the public post for any emergency events or as a crime indicator. The safety benefits are real and documented. The first is any visible camera discourage crime in monitoring areas. The video evidences helps to solve the crime and identify any suspects. The real-time alerts enable faster interventions during incidents. Because of this, there is 30% crime reduction in the monitor area which is being reported. The 50% faster emergency services response is also reported. China has the largest surveillance network in the world. London has the highest camera density per capita among the major Western cities. Now the technology stake behind modern urban surveillance. The high definition cameras having 4K resolution with night vision and 360-degree coverage can read a number plate from 100 meters in the dark. The video analysis happens at the camera itself, not sent to a distant servers. This enables real-time alerts without the delay of cloud processing, and this is known as the edge computing. The evidence, whatever is there, is stored securely with the complete chain of custody. Any tamper-proof records for the court uses on the cloud storage. And AI algorithm recognize any kind of pattern automatically and detect any kind of defects. But here is a critical question. Does crime reduction satisfy or justify the privacy cost? This is not a technical question. It is a value and governance question. The smart city or any city must balance security, the crime prevention and faster emergency responses with the privacy, the protecting citizens' right to move freely without any tracking. The right balance requires explicit policy decisions, not just technical deployment. Let us now look honestly at the privacy concern. The first concern is surveillance capitalism. When a private company operates a city surveillance infrastructure, they may use the data commercially, selling behavior insights to advertisers or insurers. The line between public safety and commercial data extraction become very dangerously blurred. The next we have the functional creep. The data collected for traffic management get used to monitor political protest. The data collected for the COVID contact tracing gets used for immigration enforcement. Each step seems small, but the cumulative effect is comprehensive and can be critical. There is issues related with the consent challenges. In public spaces, you cannot opt out for surveillance. Walking through a city centers means being filmed and potentially identified. You did not agree to this. You have no practical alternatives. You need to do that. Then there is an psychological impact also, which is known as the chilling effect. The research shows the people behave differently when they know that they are being watched. The less likely to attend a protest, less likely to speak freely, more anxious in public. A city where everyone feels permanently monitored is a different kind of city than it's as compared to its normal behavior. Now the core question is, how do we keep people safe without creating a surveillance data or surveillance state? This has no algorithm answer. It requires a political choice, legal framework, and public dialogue. The different parts of the world have responded to the surveillance challenge differently. In Europe, they implemented a strict data protection rule with significant penalties for violations. This includes the right to an explanation for any automated decision that affects you. Also, sometimes these cities ban facial recognitions, like San Francisco, Portland, and several European cities have banned government use of face recognition technology outright. The main reason is the accuracy problem. It performs worse on the dark skin tones, and the scale of privacy is also defected. US has a surveillance ordinance. Some cities requires city council approval before any new surveillance technology can be purchased by a public agencies. This brings the decision into the public debate. The four element of responsible frameworks for the good governance will be using the transparent policies, where public documentation of what is monitored and why is monitored need to be clear. Also, there should be community oversight. The independent review boards with citizen representations need to be set up. There should be sunset clauses. Surveillance program must be authorized or reauthorized periodically. They cannot run indefinitely. And also there should be data retention limits. The footage deleted automatically after a fixed number of days or hours unless specifically preserved for any type of investigation. One more important technology concept before we close this lecture is edge computing. The problem with sending everything to the cloud is, imagine a traffic camera detects a pedestrian about to step in front of a vehicle. The camera sends the image to a distant cloud server. The server runs an AI algorithm to recognize this. It sets back an alert. Even at high speed, this round trip takes 10 to several milliseconds. Potentially, this will be too slow to prevent this collision between the vehicle and pedestrian. The edge computing is the answer for this problem. The edge computing processes the data locally at a small server right at the intersection, inside the street light, or in the vehicle itself. The detection and the alert happens within 1 millisecond of time. No round trips to the cloud needed. This can benefit as 80% reduction in data processing latency and 60% reduction in bandwidth usage. Because raw video is processed locally, the only result is sent to the cloud. The smart city data architecture is the three-tier system, in which tier 1 includes sensor at the edge which will generate the raw data. The tier 2 will have edge server, which can process it and makes the immediate decision. In tier 3, we have the cloud storage, which will store the data for long term and does a complex cross-city analysis. The 5G and edge computing are partners. The 5G connects devices to edge servers at ultra low latency. The edge servers provide the real-time computation that makes autonomous decisions possible. Together, they are what makes a smart city system fast enough to be truly useful and trustable. So that's it for this part of lecture. Thank you.